Hello everyone and welcome. Today I would like to talk about rotate array. This is a very interesting question and we'll be able to explore array pointer reassignment. The solutions we'll be talking about also include slicing, juggling, and reversing. This is a very interesting topic, so let's get started. Specifically, this question provides you an array nums and asks you to rotate the array to the right by k steps, where k is non-negative. So how can we do that? One possibility is to use deck, the double-ended queue, where you pop from the right and append the pop item to the left, and you repeat this process k times. However, the deck solution has two problems. First, the space complexity is O(n) since we create a new deck container. Second, the multiplication to the nums array via the deck solution is not done in place. In contrast, the question asks you whether you can do it in place with O1 extra space. So how can we do that? There are three solutions I would like to introduce in this video, but the possibilities are certainly not limited to these three solutions. Solution 1. Juggling. Juggling means we move the item directly to the final index. But when we do that, we'll do this oftentimes in cyclic sets. That's why we call it juggling, because we are doing this moving in back and forth fashion. Importantly, the number of cyclic sets equals to the greatest common divisor of the length of nums array nk. Why is the number of cyclic sets equals to the greatest common divisor of n and k? Let's consider a simple situation. When we juggle k steps and remove, if n can be fully divided by k, then it will form a cycle after n divided by k moves. And therefore, there will be k different ways to form a cycle. If there is a remainder which is non-zero from n divided by k, then in general it will form a cycle after n divided by the greatest common divisor of n and k moves. Therefore, there will be GCD different ways to form a cycle. Now, let's move on to the next solution, reversing. The solution is pretty much self-explanatory here, but the general idea is to swap the order of the back and the front blocks, but maintain the relative item orders within the blocks. One way to do so is to reverse the order of all items first, as in this step 1 here, so that the order of the blocks is reversed, as you can see here, but the item order within the blocks is also reversed, as you can see here. Finally, we reverse the item order within the block to restore the original relative item order, as you can see here. Next, let's consider solution 3, slicing. In Python, slicing returns a new shallow copy of the original list. The new list contains copied references to the requested object in the original list. Note that slicing does not generate copies of the objects. If it does, that we call a deep copy. Importantly, the copied references take extra spaces, but those extra spaces are much smaller than the objects themselves. Also, note that when used in the left-hand side of the equal sign, it is called slice assignment. Importantly, slice assignment is different from list assignment. In list assignment, as in here, there may be new object being created and reference nums is being created to point to the new object, but in slice assignment, the reference nums already exist, and we just reassign this as value to its indices. Now, let's see how slicing can be applied to solve this question. So we have the expression here, the nums are n minus k colon, where n is the length of the nums array and k is the number of rotations. And nums n minus k means the last few k items. And the remaining items is nums colon n minus k. Importantly, we will have this simultaneous assignment where nums colon k equals to nums n minus k colon, since we rotate the last k item to the beginning, and we also have this nums k colon equals to nums colon n minus k, since we rotate the first few items to the remaining part of this nums array. One caveat is be very careful with this expression nums negative k colon. It is equivalent to nums n minus k colon when k is larger than 0, but when k is 0, it will fail to work. Another thing to emphasize is that these two expressions here are to simply redirect these indices to point to existing values without creating a new list object. In contrast, this expression here, the list assignment, will involve in creating a new list nums array object. Finally, I would like to compare these four solutions. Please feel free to pause the video to read the information here in some detail. In brief, slicing is considered the best, as it involves intuitive logic, easy coding, fast processing, and low space complexity. With the background introduced, let's write the code. In this video, I would like to demonstrate the slicing solution. So first of all, we have the n equals to the length of the nums array, and k equal to the remainder as it divided by n. Next, we have the important expression here, the last k items. So nums n minus k colon for the last k items, and we're going to move it to the beginning. So nums colon k equal to this. Okay, so nums n minus k colon is for the last k item to rotate to the beginning. Okay, and we also need to take care of the remaining subarray. So we have nums k colon and nums colon and n minus k, and that's our code for this question. Now let's submit this code to see how it works. We submit, and it's done. It's pretty good. So now let's analyze this code for complexity. So this code has a time complexity of O(n), since we're processing each of these items in the nums array by using this reassignment and slicing. So slicing and reassignment for each index in the nums array. And for space complexity, since we modify in place, so it's O1, modify nums in place. Okay. So that's all for this video. I hope you find this video to be useful. Please subscribe for more videos if you like, and I hope to see you next time soon. Goodbye.